Welcome to the third lesson in Session 5, Parallel Lines Cut by a Transversal. Parallel lines are two lines that never intersect. You can see these two horizontal lines are parallel because they'll never get closer together and they'll never get any further apart. The way for algebra learners to help them understand, I always compare them to train tracks. The wheels of a train are at a fixed width, so the widths of the train tracks have to remain the exact same distance apart, and they are parallel. So parallel lines never intersect. Now a transversal is a line that intersects one or more lines in the same plane. So as you can see, we have a pair of parallel lines, and then that third line is considered a transversal. Now when parallel lines are cut by a transversal, the following angles are formed. The first type of angle is a vertical angle. A vertical angle is a pair of opposite angles made by two intersecting lines. Now you don't need to have parallel lines in a transversal to create vertical angles. Anytime two angles intersect, vertical angles are produced. So in this diagram, we have four pairs of vertical angles. Angles 1 and 4, angles 2 and 3, angles 5 and 8, and angles 6 and 7 are all vertical angles. And what we need to remember about vertical angles is that they are congruent. So as you see this diagram, angle 1 is equal to angle 4 because they are vertical angles. Angle 6 is equal to angle 7 because they are vertical angles. Next we have corresponding angles. Corresponding angles are a pair of angles in the matching corners. Now in this case you have to have parallel lines cut by a transversal in order to produce corresponding angles. So in this case, angles 1 and angle 5 are corresponding angles, angles 2 and 6, angles 3 and 7, and angles 4 and 8. Those are corresponding angles because they have the same position at different intersecting lines. And again, if parallel lines are cut by a transversal, corresponding angles are congruent. Next we have alternate interior angles. Alternate interior angles are a pair of angles on opposite sides of the transversal but inside the parallel lines. So in this case, angles 3 and angle 6 are opposite alternate interior angles, and angle 4 and 5 are alternate interior angles. And again, if parallel lines are cut by a transversal, alternate interior angles are congruent. Next, we have alternate exterior angles. Alternate exterior angles are a pair of angles on opposite sides of the transversal and outside the parallel lines. So in this case, angles 1 and 8 and angles 2 and 7 are alternate exterior angles. And again, if parallel lines are cut by a transversal, alternate exterior angles are congruent. Next we have same side interior angles. Now same side interior angles are a pair of angles on the same side of the transversal and inside the parallel lines. So in this case, angles 3 and 5 are same side interior, and angles 4 and 6 are same side interior. And if parallel lines are cut by a transversal, same side interior angles are supplementary. So remember, definition of supplementary means they add to 180 degrees. So same side interior angles are supplementary because they add to 180 degrees. Next we have a linear pair. A linear pair is a pair of adjacent angles that combine to form a straight line. Now for a linear pair, similar to vertical angles, you do not need parallel lines to cut by a transversal in order to produce a linear pair. Anytime that two lines intersect, linear pairs are formed. And in this case, there's going to be quite a few of them. Angles 1 and 2, angles 3 and 4, angles 5 and 6, angles 7 and 8, angles 1 and 3, angles 2 and 4, angles 5 and 7, and angles 6 and 8. Any angles that form a linear pair are supplementary. Here we're going to move on to some examples. So we're going to use the given diagram to answer the following questions. What we need to know before we start is that line A and B are parallel, and my third line acts as the transversal. So first, how would angles E and G be classified? So if I look at them, they are on the same side of the transversal, and they appear to be in the same position of those two angles. So E and G are corresponding angles. Second, we look at angles A and H. Now, angles A and H are on opposite sides of the transversal, and they are outside of the parallel lines. So in this case, we have alternate exterior angles. And number three, we've got angles D and G. Angles D and G are considered vertical angles. All right, for number four, if angle B is 135, then we need to find angles C. Well, what we need to know is angle B and angle C are same side interior angles. And same side interior angles are supplementary, meaning they add to 180 degrees. So if angle B is 135, then 180 minus 135 leaves me with 45 degrees. So if angle B is 135, angle C would be 45 because they're same side interior angles, meaning that they're supplementary. Lastly, I'm still using the given that angle B is 135 degrees. Now I need to find angle G. Angle B and angle G are alternate interior angles. They're both inside the parallel lines on opposite sides of the transversal, making them alternate interior angles. Now, by definition, alternate interior angles are congruent. So if angle B is 135 degrees, then angle G would also be 135 degrees. So that wraps up our lesson on parallel lines cut by a transversal. Please email us if you have any questions, and good luck on the quiz.